In 2018, EU leaders agreed on a new direction in the development of biofuels to be achieved by 2030. This new direction is contained in the so-called Renewable Energy Directive 2, or RED 2, and will take effect gradually from this year 2022. In RED 2, the European Union is determined to completely abandon biofuels whose raw materials come from food and feed, up to 0% by 2030. So what kind of biofuels do they want? This is where the attraction for our startup After Oil Indonesia lies. Since RED 2 was agreed 4 years ago, we have seen this as a big opportunity for our country even though it is far from Europe. Why is that? The European Union introduced a new biofuels called advanced biofuels. This is a new type of biofuels whose feedstocks are completely different from existing biofuels. If the majority of biofuels on the market today still use palm oil, soybean oil and rapeseed oil, the feedstocks that are the target for use in the production of advanced biofuels have been specifically determined in Annex A of THE Directive. So this is where the big opportunity for us in Indonesia is. All of the 17 types of feedstocks in Annex A Directive are available with us. Even better because some of them are available in abundance, such as rice husks, straw, corn cobs and so on. However, these materials, which are mostly agricultural waste biomass, certainly cannot be exported to Europe right away. Technology is needed to convert them into fuels according to their target. So this is where the research and development that we have been doing for the last 4 years. The focus is on developing the most suitable technology to produce advanced biofuels from agricultural waste materials that are abundant in us. The key technology for converting biomass into advanced biofuels that we have patented is this fast pyrolysis autothermal reactor. High temperatures above 500 degrees Celsius are needed to convert biomass into bio-oil. Of course, to produce this high temperature requires high energy as well, so that the current fast pyrolysis process tends to be expensive in energy costs. Our technology is different. In agricultural areas, in biomass production centers, the cheapest energy is of course biomass itself. So the autothermal reactor that we designed uses a small portion of the biomass to produce high temperatures, while the high temperatures are used to process most of the biomass into bio-oil. With the cost of raw materials for agricultural waste being cheap, the cost of processes, especially energy, which is also cheap, the bio-oil that we produce can also be very cheap. This bio-oil is widely known, especially in North America, and even has a standard, namely ASTM D7544. It can already be used as fuel for boilers, heating oil in winter and so on. However, we have also developed the next technology to upgrade this bio-oil into advanced biofuels, especially for the gasoline and industrial fuels. The essence of this second technology is catalytic cracking as well as fracked ional distillation, which is also energy efficient, because the heat energy source can use waste heat from the first reactor, namely the fast pyrolysis reactor which produces the bio-oil. We continue to develop these technologies. The ultimate target is that all fuels currently on the market can be produced from the bio-oil feedstocks that we produce. From this bio-oil with LTG gasification we will process it into syngas, then we will further process the syngas into synthetic crude or syncrude through Fischer-Tropsch's synthesis. After it becomes syncrude, it can be processed using our previous reactor, namely catalytic cracking and fractional distillation to produce green diesel, sustainable aviation fuels or SAF, biogasoline and even bio-LPG. These are advanced biofuels which are very clean, carbon neutral, free of SOx and NOx, and of course they are also renewable.